Hi CalcAB, this is page 8 of your binder. This is a graphing calculator problem. I believe the AP test will allow you to have a calculator, but they've said that you won't need to have a calculator. So some of the skills here I don't feel like are going to show up on your test, but I think the ideas could. So that's why I'm still going forward with the problem. Grass clippings are placed in a bin where they decompose. For 0 less than or equal to t less than or equal to 30, the amount of grass clippings remaining in the bin is modeled by this function where a of t is measured in pounds and t is measured in days. I'm going to plug that function into my graphing calculator. So my function is in y1, and part A says find the average rate of change of a of t over the interval 0 to 30 and indicate units of measure. So that's a two-part question. One is find the average rate of change, and the other is make sure that you write down the units of measure. And I believe that they would give points to each of those ideas. Average rate of change is just the slope of the endpoints. So we're going to have to come up with points for the endpoints of our function. Have to have a of 30. And those are values that I can get easily with my calculator. So on my home screen, y1 of 0, y1 of 30, now average rate is the slope between those points. So the value of the average rate of change is negative 0.1968. And then the next step is to come up with the units. Your numerator is collecting pounds because these are values of A. So pounds minus pounds is going to give you pounds. And then your denominator is days. So the unit here is pounds per day. Part B says find the value of A prime of 15. And using correct units, interpret the meaning of the value in the context of the problem. So we can get this on our calculator by doing n derive. So take the derivative of y1 with respect to x at x equals 15. So it's negative 0.1636 pounds per day. And just like in the last problem, the units are still pounds per day because you're talking about how the function a is changing. I also want to go back to how you could do this by hand because that's the calculator way. This is an exponential function. And remember that an exponential function, I'm going to go to a basic example here. If it's y equals 6 to the x, y prime is itself times the natural log of 6. So in this problem, because a of t is this, a prime will have the coefficient times the exponential part multiplied by the natural log of the base. And if you plug t into this function, you'll also get the negative 0.1636 pounds per day. The next part of the problem is to interpret the meaning of the value. And I think this is something that you really need to remember anytime you're writing the meaning, is that this is talking about the derivative at a very specific day. And the function might be changing differently on a different day. So I would begin your sentence by saying, when t equals 15, or on the 15th day, the amount of grass clippings is decreasing by 1636 pounds per day. The fact that it's negative is why I'm using the word decreasing here, and I don't want to do double negatives on the value and on the words. Part C is a classic problem. Find the time for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin over the interval 0 to 30. So the function is a of t, and we need to figure out when the average amount is equal to, or when this time is equal to the average amount. And the average amount idea right here, and this can be done with a calculator or without a calculator, so that's why this is a really important idea. So the calculator can help us work through this calculation, but on the AP test maybe they'll give you something easier to see. So on my home screen, I'm going to do the integral from 0 to 30 of our function. And then I divide by 30. And that represents the average value over the 0 to 30 time interval. So now go to your calculator. All right, so in my calculator, we've got our function, and then we set it equal to the average value. So that's 2.7526. My window should be from 0 to 30, because that's the time interval we're on, and make my y-min like -5 to 5, just to see a nice window. Calculate the intersection. $12.4150. Remember that when you're showing the work, you want to make sure that you show the calculus. So all of this right here is calculus, whether or not you use a calculator. And so you're providing the equation that you're solving, the calculus idea, and then the final answer. Part D says for t greater than 30, L of t, the linear approximation to A at t equals 30, is a better model for the amount of grass clippings remaining in the bin. Use L of t to predict the time at which there will be 0.5 pounds of grass clippings remaining in the bin. Show the work that leads to your answer. The linear approximation, is a fancy phrase for find the tangent line. And any tangent line is going to need to have a point and a slope at the value that is in question. So we're talking about at t equals 30. So we need A of 30, which we've already found above, and we also need A prime of 30. We have found the values above, but just because there's a lot of calculations happening, I'm going to store the values and make sure that we're using the most accurate ones. So y1 of 30, I'm going to store this as our y value, so alpha y, and then n derive at 30, and I'm going to store this as m because the derivative we like to think of as the slope. So even if I write down the first 4 decimal places, I'm still going to use these values in my calculation I know it's hard to write down all of these, so I'm going to write down the first 4, but I'm still going to operate with m and this y value. So we have our values stored, and so now we just have to write the equation of the tangent line. So it'll be y is equal to negative 0.0560 times x minus 30. When you're talking about linearization, the text is using L of t, so we can make the replacement. And then they're saying use L of t to predict the time at which there will be a 0.5 pounds of grass clippings remaining in the bin. So that's a go backwards idea. We know that there's 0.5 pounds, which is our output value. And now we have to go backwards to figure out this p-value. I'm going to do that, and I want you to try to do that on your own. And remember to use your stored values to come up with the most accurate answer. So my final answer is 35.0544 days, and that's using the stored values. And that is more accurate than if you'd done some rounding here at the beginning of the problem. So that's it for page 8.